Hello everybody. In this video we will be uh, looking at how to investigate the relationship between two quantitative variables. We will look at a graphical tool called Scatterplot to study such relationships, and also we'll be looking at a quantitative measure called correlation coefficient to measure the strength and direction of such relationships. All right, so let's get started. So first of all, we say when two variables measured on the same cases or units are called associated if knowing the value of one variable tells us something about the values of the other. So we are not necessarily talking about a causation here. That is, we're not talking about the change in one variable causing change in the other variable. We are simply looking at whether the value of one variable tells us something about the value of the other. So a couple of examples here. We can look at the relationship between the first test score and the final exam score. Does it so it a lot of the time, so it tends to be the case that the first test scores, a good first test score means that a student will also get a good final exam score. The relationship between stress and lack of sleep, SAT scores of high school students and their future college grades. Liquid hair, that's a hair product versus the growth of new hair follicles, and the another example would be the number of beers consumed versus the blood alcohol level. Now, in each of these cases, we are looking at the relationship between two variables. So when we're looking at the relationship between two variables, usually one of them is called the response variable, and the other one is called the explanatory variable. So in the first example, the relationship between the first test score and the final exam score, the final exam score would be the response variable, and the first test score would be the explanatory variable. And so what it means is that by knowing, so we are asking, by knowing the first test score, does it tell us anything about the final exam score? So here, final exam score is the response variable, and the first test score is the explanatory variable. In the second example, stress would be the explanatory variable, and lack of sleep would be the response variable. In the third example, the SAT scores would be the explanatory variable, and the future college grades would be the response variable. Liquid hair product versus this, and then the number of beers would be the explanatory variable, and then the blood alcohol level would be the response variable. So a response variable measures or records an outcome of a study. An explanatory variable explains changes in the response variable. So let's look at the example of the number of beers drank versus blood alcohol level. In this example, we have this data set where we have 16 cases of students, and for each student we are looking at the number of beers consumed by the student, and then looking at the blood alcohol level of that student. So in this study, the number of beers will be the explanatory variable, and the back would be the response variable. The question is, how do we study the relationship between the number of beers and the blood alcohol level? So to get some ideas, we would want to plot this data. So how would we plot this data? Well, for each student, we are going to plot this point. So we're going to plot, for example, the 0.5, 0.1, 2, 0.03, and so on. So we plot them in the XY plane. And then once we plot them, we will be looking for an overall pattern and deviations from the pattern, and then we'll see look at a numerical measure of the overall pattern. So here is a plot. So along the horizontal axis here, we are plotting the number of beers, and along the vertical axis, we are plotting the blood alcohol level, or in short, I'm just going to say BAC. So for example, here you see that for student number 7, we have the 0.3 and 0.07. So we are plotting 3 and then 0.07 along the vertical axis. So we get this point right here. So this is the point given by the coordinates 3 and 0.07. So this is how we plot all these points. This plot here is called a scatter plot. So when you draw a scatter plot, the explanatory variable is plotted along the horizontal axis, and the response variable is usually plotted along the vertical axis. So here I have instructions for how to create a scatter plot or scatter plot using TI-84 calculator. In Canvas, if you recall, I posted instructions for how to enter a data set or a list in the calculator. So you have to use that, and then together with this set of instructions will allow you to draw scatter plots like the one that we did in the last example. So now, once we have the scatter plot here, then we ask ourselves a couple of questions. So what kind of relationship do we see among the two variables here? So the first question to ask, what's the form of this relationship? That is, by form, I mean, does this relationship look like a linear relationship? Does it look like a curve that's not a line? And also the direction of this relationship. That is, do the two variables tend to increase at the same time, or do they tend to decrease together? and also the strength of the relationship. That is, in this problem, in this example here, for example, we see that the overall pattern looks like a straight line, and the overall pattern also is a positive relationship, because as the number of beers increases, so does the blood alcohol level. So the two variables tend to increase together here. So that's called a positive relationship, and the opposite would be negative relationship. And the strength would be what? Well, if we are saying that the overall pattern is a straight line, then the strength of the relationship means how close are the data points to that straight line overall pattern. So so from the scatterplot, we look for overall pattern of the form, direction, and strength. By form, we mean whether the graph looks like a line, does it look like a curve, does it look like a cluster, or does maybe there is no pattern. And then direction, by that we mean positive, negative, or no direction at all. So positive would mean that the two variables increase together, or the two variables tend to decrease together. Or maybe when one increases, the other one decreases. By strength, we are talking about how closely the points fit the overall pattern. So here I have a bunch of scatter plots. In the first two scatter plots, I would say that the overall pattern is a line. In the first scatter plot, notice that as the explanatory variable increases, the response variable is decreasing, so this is a negative relationship. In the second picture, as the explanatory variable increases, so does the response variable, so this is a positive relationship. In the next two pictures here, I wouldn't say that the graph looks like a line. I would say that the graph looks more like a curve. So these two are examples of non-linear relationships. There is an overall pattern, it's just not a line. And in the last two examples here, these two scatter plots, in the first one, notice that you might say, well, there seems to be like a horizontal line pattern. Well, notice that what would that mean then? Well, as the explanatory variable increases, it seems like the response variable stays about the same. So since it stays about the same, there is no relationship. And in the last one, it's kind of looks like a clusters of points here. The points are kind of all over. There is no pattern that stands out. So in this case also there is no relationship. So like I said, positive association between two quantitative variables would mean that high values of one variable tend to occur together with high values of the other, and negative association or relationship would mean that high values of one variable tend to occur together with low values of the other variable. So here are two examples of perfect linear relationships. So one of them is a positive relationship, the other one is a negative relationship. So in the first scatter plot here, as the explanatory variable increases, so does the response variable. Here, as the explanatory variable increases, the response variable decreases. And in these two scatter plots, we have no relationship. So in the first one, we have like a perfect horizontal line, but that doesn't mean there is a relationship, even though they fit a line, because if you think about it, what it means is that as the explanatory variable increases, the response variable stays the same. So changes in the explanatory variable have no effect on the response variable. And also the other one doesn't, it has the same explanation, except that it's not a perfect horizontal line. The strength of the relationship between two variables can be seen by how much variation or scatter there is around the main form, right? So if the overall pattern is a straight line, then the closer the points are to the line, the more strong the relationship is, and you can explain the weaker relationship in a similar way. So with so the first scatter plot here, it's almost like a perfect straight line. So in this case, the relationship is very strong. So the strength of the relationship is very high because the data points, they fit closely together with the overall pattern, overall linear pattern. In the second, compared to the first one, the second scatter plot, even though the overall pattern is linear, positive, however, the strength of the relationship is not that high. It is in fact a weak relationship, and the reason is the data points are kind of farther away from the overall pattern or the overall straight line compared to the first one. So this would be, the second one would be a weaker relationship than the first one. Here I have two scatter plots. In the first one, notice for every state in the United States, we have plotted state median household income versus the state per capita income. So per capita income versus the median household income in every state. So this is the scatter plot that we get. So here the cases are the states, and for each state we look at the median household income and the per capita income. In the second one, we are looking at the two variables. One of them is the average number of heating degree days per day, and the other one is the average amount of gas consumed per day in hundreds of cubic feet. So again, along the vertical axis we are plotting average amount of gas consumed per day in hundreds of cubic feet. So this is about heating a home, right? So you are heating a home. The amount of gas needed depends on the number of heating degree days. Let me explain the heating degree days. So let's say the base is 65 degrees. So you're trying to keep your home at 65 degrees, and if the outside temperature, let's say, is 40 degrees, then the number of heating degree days would be 25. So that's the difference between the temperature outside and inside. So depending on that, how much gas you use depends on that. So we see that there is a very strong relationship in the second scatter plot. In the first scatter plot, even though there is an overall linear positive pattern, this is a relatively weaker relationship. All right, so whenever we work with data points, we always need to be careful about outlier data points. So an outlier is a data value that deviates quite a bit from the overall pattern. In some sense, it should look unusual or unlikely. So if you look at the two scatter plots here, in the first one, I would say there isn't any outlier. In the second one, the one that is marked in red, that looks like a that looks deviating a lot from the overall pattern, so that could be a outlier. Here are two other examples on outliers. So in the first scatter plot, we are using colors here. Notice that the data points corresponding to female cases are in red, and data points corresponding to male cases are in blue. And we are looking at the blood alcohol level versus the number of beers divided by weight. So number of beers as a percent of weight here. And so notice that I have a data point way up here. And is that an outlier? Not quite, because even though it is away from all the other data points, but it is close to the overall pattern. On the other hand, in the second picture, the marked data point right here is an outlier, because it is quite a bit away from the overall pattern here. So the data value in the first scatter plot that is marked in blue, that is kind of expected for such a high number of beers. It doesn't deviate from the overall linear pattern. All right. Sometimes what may seem like a single trend may actually be multiple relationships. And so can the data be divided into categories to reveal trends? So what do I mean by that? Let me explain that by this example. So along the horizontal axis, we have the number of native species, and along the vertical axis we have number of exotic species, right? And so if you plot these points, you see that there is an overall linear trend, a positive linear trend here. However, notice that if we divide the data points into categories of habitats, right? So now there are 5 different habitats that we look at. Maybe we collected data from 5 different habitats, and the data points for each habitat is assigned a color. So for one habitat, the data points are drawn in red. For another one, the data points are drawn in yellow, and so on. So once you put these colors in the picture, then what you realize is that what seemed like a single relationship is in fact a bunch of negative relationships, right? So overall, if I didn't put the colors, it looks like overall there is a positive relationship, but in fact what's going on here is that within each habitat there is a negative relationship between the number of native species and the number of exotic species, which kind of makes sense. If the more the number of native species is, the less the number of exotic species should be. Colors are also helpful in comparing categories of data values. So in this picture, what we have is we have time along the horizontal axis, and we have the racing records along the y-axis. So this is the record for 10K races. So what's the record for 10K races? So we've drawn the data points for men and women. By doing so, if we didn't make that distinction, then it may seem like there is no relationship. But within each category, you see that there is a negative relationship. So gender categorization leads here to strong negative relationship within each category, which wouldn't be clear if we didn't make this. If we didn't put colors or in some way distinguish. If we didn't distinguish the data points for men and women. So in this case, putting colors on the data points according to some category reveals can be used to compare the two categories for these racing records. So here I have another picture where, again, for men and women. So here for men we are using open circles, and for women we're using filled-in circles. And we're looking at, on the horizontal axis we have the lean body mass, and on the vertical axis we have the metabolic rate. And here we see that the same overall trend, positive linear trend for both of the two categories, for men and women. We see the same pattern. We see a stronger association for women than men, because if you look at it, the data points for women are closer together than the ones for men. And also notice that the men have both higher lean body mass and metabolic rate than women. Okay, so let me go back to where I ended. Let me do slides here. All right, so let's do some exercises. So when creating a scatter plot, what axis should one use for the explanatory variable? Well, I want you to pause, answer it for yourself, and then come back. And so for each of the questions that I'm asking now, you should pause, answer it yourself, and then unpause to see my answer. Well, in this case, remember the explanatory variable is always drawn on the horizontal axis. A study is conducted to determine if one can predict the yield of a crop based on the amount of yearly rainfall. Which variable should be the response variable in this study? Well, so since we are really, if you think about the study, we are trying to look at what is the effect of rainfall on the crop yield. So the response variable here should be the yield of crop. A researcher is interested in determining if one could predict the score on a statistics exam from the amount of time spent studying for the exam. Which variable is the explanatory variable in this study? Well, again, we are trying here in this study, what we are trying to predict the score on a stats exam by looking at the amount of time spent on studying for the exam, right? So clearly the explanatory variable here should be the time spent studying for the exam. A scatterplot is a graphical tool for displaying the relationship between what kind of variables measured on the same individuals. Well, scatterplots are only drawn for quantitative variables. So if you have two quantitative variables, that's when so a scatterplot is used for quantitative variables. Here we have a researcher measured the height in feet and volume of usable lumber of 32 cherry trees. The goal is to determine if the volume of usable lumber can be estimated from the height of a tree. The results are plotted. So along the horizontal axis, height is plotted and the volume is plotted along the vertical axis. So you're looking at the height of a tree versus how much what volume of lumber you get from it. And we did this for 32 trees, right? So here we want to select all the descriptions that apply to the scatterplot. There is a positive association between height and volume. There is a negative association between height and volume. There is an outlier in the plot. The plot is skewed to the left. Okay, so I hope you paused and thought about it for a bit, and the answer is A and C. So there seems to be an overall trend that both of them, as height increases, the volume is increasing, and there is an outlier because if you think about the data point just right here, which is where the height is between 65 and 70 and the volume is around 70 here. Okay, here we have another scatter plot where we have weight of a car along the horizontal axis and the fuel efficiency of a car along the vertical axis. So the fuel efficiency is measured in terms of miles per gallon or mpg, and the weight is in terms of pounds, thousands of pounds. So when you see the data point, the 4.0, that actually means 4,000 pounds. Okay, what can we say about this study from the plot? There is little difference between trucks and automobiles. So here, notice that we have two categories here, automobiles and trucks. And the data points for trucks are plotted using X, and the data points for automobile is plotted with using filled-in points. So trucks tend to be higher in weight than automobiles. Trucks tend to get poorer gas mileage than automobiles. The plot is invalid as scatter plot is used to represent quantitative variables and the vehicle type is a qualitative variable. So again, pause and think about which of the four statements are true. Okay, so basically the answer is B and C, that the trucks tend to be higher in weight than automobiles. You can see the data points for trucks are overall to the right of the data points for the automobile. And then the C is also correct because the data points for trucks are generally in the lower portion of the graph, and the data points for the automobile are overall above the data points for the trucks. So trucks tend to get poorer gas mileage than automobiles. When we draw scatter plots, scale is a big deal. How if you use inappropriate scale, that might lead to some deceitful patterns. So in the first two scatter plots, so all the 4 scatter plots here are created using the same data, but you can see that how much different pictures we obtain. So the first one and the second one, clearly the scale picked is bad, and so what would be the best way of picking scale? Well, plot roughly square, allowing the variables to have similar spacing. So use about the same scale for both of them. Points should occupy all the plot space, no blank space. So this third picture here is the best scatter plot here. Okay, so I'm going to stop the video here. In the next video, we will be talking about correlation coefficient. So that is, we will be quantifying the strength of relationship between the strength of linear relationship between two variables. All right, I'll see you in the next video.